Hi everyone, in this video we're going to take a look at some more options for linking objects in Maya. In this video we're going to take a look at constraints, and constraints are used primarily when rigging objects, whether they be characters or vehicles or things of that nature. In some previous videos we've had a look at some other systems which are sort of work in a similar way, such as the combine function, which pretty much just combines polygon objects together into a single object, and also parenting and grouping, which allows us to link objects together to a master or a parent object or a group, and that allows us to move, rotate and scale them all together or individually. So let's take a look at constraints. You can see here I've got a polygon cube, and I'm going to just create a locator as well under the create menu. A locator is just basically just a little object like this, and generally we use them as handles or just positioning objects. So it's really just a point in space that's given a little visual representation like this. Most software packages have something along the same lines as a locator, and sometimes they can be called null objects depending on the software that you're using. So in this case what I'm going to do is constrain the cube onto this locator in a few different ways to show you what the different options are. I might just create another one just in case. Okay, so let's have a look at the constrain menu. To get to the constrain menu, you'll need to make sure you've got your menu set to animation, just up here in the top left corner, and you can then go across to the constrain menu over here. Now what I'm going to do is just snap this menu off so I can keep it open, and it'll make it a little quicker to go through them. So essentially what we have is a number of different constraints that we can use. Now the first 5 are more or less the most basic, and these are the ones really I'm going to go through. Starting at the top, we've got point. Now point basically is referring more or less to a point in space, and that's essentially a position. So the attribute of our object that's going to control is the position, or the translate attributes. So on the cube it's going to control the translate X, Y or Z attributes over here. So the way that the constraint works is we select the locator, which is sort of the master object, and then what we do is we select the constrained object, which is going to be the cube. So I just hold shift and select that as well. I'm then going to come up to the option box because I want to show you the options. And by default, I'll just go to edit reset settings here just to show you what the default settings are. So by default we've got maintain offset, which is switched off. Now what that does is it tells the constraint to either keep the constrained object, the cube, in its current position when it links it to the locator, or it will allow the cube to adopt the attribute values of the locator depending on the kind of constraint that we're making. In this case it's point, so it's going to be the position or the translate. So with it turned off, the cube will jump to the position of the locator. Now I need to kind of clarify that in that the cube's pivot point will move to the position of the locator. So by pivot point, if I turn the move tool on, the locator for the move tool, or the manipulator for the move tool, appears at the object's pivot point. So basically, if I constrain those objects, this position on the cube will appear at this locator when maintain offset is switched off. Okay, but if the pivot point is in a different location, if I hold D, I can actually reposition the pivot point. If I move this over here, what would happen then if I constrained it is the cube would shift across until this pivot point position was on the locator. So that would mean the cube would end up sort of down in this area here. Okay, now that's kind of important because obviously you need to know what to expect when you're creating these constraints. So I'm going to do that in a second. The offset basically allows us to sort of almost pre-position the object before we constrain. So these values are basically x, y, and z values because we're talking about position. So for example, if I set this to 5, that's 5 grid spaces up. So what should happen there is the cube will link to the locator, but the cube itself will shift 5 units up above the grid before it does so. Okay, I'm just going to leave it at 0. I'm going to skip these settings here, animation layer and override. Okay, and we'll just jump down to the next one. The constraint axes basically are the axes which will be constrained by the locator. So you can choose all the axes, in which case X, Y, and Z movement for the cube would be controlled by the locator, or we can just select specific axes. So I'll do both so that you can sort of see what happens. So I'll select my locator, my master object, and I'll select my constrained object, and I'll just constrain this with the default settings. So what we should see is the cube jump to the locator like that. So you can see over here in the channel box that the translates for the cube are now highlighted this light blue. That's telling me that the object, these transformations or attributes for this object are constrained to something. Okay, and I can see down here I've got a point constraint in the shape node just here. Now if I click on that, I can see that it's constrained to this locator 1. So basically the way that this works now is if I select the locator, I'll just press 4 on the keyboard to go to wireframe for a second, and I'll select the locator. You can see in wireframe mode, when the locator is selected, the cube turns this magenta color, and that indicates that there is some kind of controlling input connected to the cube, which is being controlled by something else. So you'll often see magenta shapes when you, for example, when you're doing modeling, and if you do like a mirror cut function where you're mirroring your object across, when the history is still active for that object, before you delete the history, you'll see that the object wireframe is actually purple, and that's because it's got an input from the mirror cut node. So you can see here what's happening is that the locator is controlling the position of the cube. It's controlling those translates like that. So let's have a look at when we link this with maintain offset. So I've just undone that, so it's no longer constrained. I'll activate maintain offset and hit apply. So you can see there I'm getting the linked blue designation up here in the channel box, but you can see that the object didn't move. If I select the cube, you can see that it does control it, however. Okay, so I'm just going to undo that again to there, and this time what I'm going to do is just constrain 1 or 2 axes. I'll just do 2. I'll do X and I'll do Y as well. So what this is going to do is it's going to, when I apply it, you can see up here it's only constrained X and Y, which is what we said here. So Z is completely free. So what this means is the locator will control the up and down motion of the cube. It will control the left and right motion of the cube, but it doesn't control the forwards backwards motion of the cube. So I can kind of customize it using that setting to tell it to specifically control only the axes that I want it to control. So another thing that you need to be aware of is that when you have a constraint coming in like this to an object, and you get these blue highlights on your numbers, basically you can't keyframe those the way that it's set up like this. So pretty much if I select that, for example, and I right click it and I hit key selected, okay, you can see it sort of goes green like that, And if I move this over here, and then I come down the timeline, and I key that, you can see that I don't get any animation. Okay, so basically it's the actual keyframes themselves. You can see here that the keyframes are interfering with the control of the locator, in that when I move the locator like this, the cube isn't moving. Okay, it will move up and down because I didn't keyframe the y-axis, and it still doesn't move because the locator doesn't control forwards backwards. But the keyframes are basically locking the object in place. However, the animation that I created with those keyframes doesn't work. So it's sort of nullifying both of those controls in that manner. So you can't really keyframe those objects when they're constrained like that. You can, however, keyframe any of the other settings that haven't been constrained. So for example, I can still keyframe the z-axis on this cube. I'm just undoing here back to before I made those keyframes. So you can see now they're blue again instead of green. So I can still select the cube and I can still keyframe the z-axis like this. So that animation will still work. But if I want to animate the y-axis or the x-axis, I'll have to do it up here, like this. So that's essentially how that works. All right. Now, most of the other constraints are the same. So the explanation for them is all more or less the same, with the exception of the aim constraint, which I'm going to show you separately. So I'm just going to reset that, and we'll take a look at a couple of the other options. So let me just reset that. Back to there. So I'm no longer constrained. Actually, I am. There we go. Okay, so I'll skip aim, come back to that, and we'll go to orient. So basically, orient is rotation. All right. Now, aim also is rotation, but it's different. With the orient, it essentially will link the rotation of one object to the other object. So I'll select the locator as the master, I'll select the constrained object, which is the cube, and I'm just going to constrain it as you see here, like that. So basically, you can see if I move this, it does nothing, okay, but if I rotate it, it will rotate the cube, like that. All right. Once again, maintain offset and so on. If we take a look at the maintain offset, we'll just actually turn that off. What I'm going to do is rotate this around just randomly, and then I'll select this and hit apply. You can see that when maintain offset is off for orient constraint, it's the rotation that will jump to the same rotation as the locator, rather than it jumping to the position. Okay, so it's all contextual based on, maintain offset is contextual based on the type of constraint that you're using. Okay, so scale, that's pretty much exactly what it says. It's just size, more or less. So I'm not going to show you that one. It's exactly the same setup, except that it adjusts the scale. Parent's a bit different. Essentially what parent does is it gives you the option of linking both translate and rotate in a single constraint. And you can choose, once again, which axes you want to control. So for example, what I can do is constrain perhaps, let's say I go X translate and X rotate, and perhaps the Y axis as well for both, and I'll constrain that onto there, just hit apply. So you can see that's occurred up here. So basically if I rotate X, I get the X rotate. If I rotate the Y, I get the Y rotate. And if I rotate Z, that is rotating as well, which is sort of odd. That's actually the position that's changing. You can see there. So this object's not actually spinning, it's the actual object that's rotating around. Now, if I use the move tool, I get Y and I get X, oops, like that, but I won't get Z. Okay, but what you can do is actually constrain an object to more than one master object. So what I could do here is select the second locator and just set this up so that it will constrain only the z-axis, like that. So now I've got this object which will control the z-axis movement and rotation, like this, and I've got this one here that can control this movement. All right. So all of these kind of links are the kind of links that you quite often will use when you're adding a rig to a character. Okay. All right, so let's take a look now at the aim constraint, which is a little bit special. To show you this one, I've actually got a couple of objects here. What I've done is just made a couple of really dodgy basic eyes. And what I'm going to do is use an aim constraint to control them. But I'm going to sort of do like a little rig setup, a little mini rig here, so you can kind of see a little bit of the process that's involved. I'm going to need a couple of locators, so I'll just create a locator. And the locator, when you create them, like lights and cameras and some of the other objects, always appears in the middle of the grid. So I'm going to duplicate this, and then what I'm going to do is I'm going to duplicate it a couple more times. But I'm going to turn grid snap on and actually move this across until it snaps right in front of the eye, like this. And then I'll do the same thing over here, like this. Okay. So basically what I want to do is I want this locator here to represent the head of my character. And I want the locator here to control the position of these two locators on either side. These locators are going to be what the eyes will aim at or target, and that's what we're going to use to link them together, this aim constraint. So I'm going to start off by selecting my first locator and my first eyeball, and you can see here that the eye's pivot point is right in the middle of the eye itself. That's important, so it actually spins around the center of the eye. Okay, I'll turn grid snap off as well. So I've got my two objects selected. I'm going to go into aim, and you can see the settings for this are a bit different. They're a little bit more complicated. The first thing I want to do is select maintain offset. Now the aim vector, basically here what we need to do is put a number 1 in the axis that the eye is looking along. Now in this case it's looking along towards the object in a positive Z direction. So generally what we would do is type in 1 for the Z value just here. So this, don't forget, this is X, Y, and Z. The up vector is the up direction in the scene or of the object, okay, and that's going to be Y. So we put a number 1 in Y. And then we've got world up type, okay, and you can select either just a direction, which is vector by default, or you can select like the object up direction or the world up direction from this drop down. We'll just leave it on vector. You can also set the world up vector here, so it sort of knows which axis is the world direction up, which is automatically set to Y. And then we've got the constraint axes, and I'm just going to set that to all. Actually, you know what? Quite often what we would do is probably not set the, let me just turn on the rotation. We would probably not set the Z axis because the eye is not going to kind of spin side to side. It's just going to go up, down, and left and right. So what I might do is just set it to X and Y for this. And what I'll do is hit apply. Now you can see nothing over here changed, but we did get that link. So technically now what should happen, I'm just going to freeze these transformations, which I forgot to do before. So I'll just highlight them, right click and hit freeze, translate, and that's just lock those two locators in this position. Technically now if I move this around, the eye should always point at the target, like this. So that one works. So now I'm going to do the other one. So I'll just select this locator and this eye and apply. And we'll just test that as well. Okay, that's cool. All right, so usually now what I would do is I would select both of these objects and I would lock off the translate Z value. And to do that, I just come over the channel box, right click and hit lock selected. Now the reason for that is that I don't want to be able to move the object away from the eye or into the eye. I want these targets to stay at this distance. Now obviously if I select both of those objects, I can kind of move it around and both eyes move together. Alright, what I'm going to do here is I'm going to select both of the eye targets, and you can lock this one as well if it isn't locked already. Then I'm going to hold down Shift and select the center locator here, and I'm going to parent them. So I'll go Edit Parent. Okay, now you can see here that they've actually jumped. Alright, now that's probably going to be because this locator has a translate value. So I'll just undo the parent by hitting Z, and I'll freeze the translates here as well, like that, and then I'll reparent those like that. You can see now they're staying in position. Alright, so once again what I can do with this one is lock off that translate Z so I don't accidentally move it. So we'll just go lock selected. So now I can basically move all of them around at the same time, like that. Okay, so then what we do is we want to have these eyeballs fixed to the head. So what I'm going to do is parent them onto this object. So I shift select both eyes, shift select the locator in the middle, which is the head, and I parent those. So Edit Parent, like that. So now if I move the eyes, or sorry, move the head, the eyes move with it. And what I can also do is parent this locator onto the head as well. So what we can do here is go Edit Parent. So now if I move the head, it moves everything, and I can independently position this where I want the eyes to be, like this. So that's essentially what you use sort of the linking. That's one of the things you can use all the linking systems for, whether it's just regular parenting, grouping, or using constraints. But that's also a sort of a specific look at what the aim constraint does. It basically allows you to make one object point towards another object, and you can use it to set up controls. So likewise, you can see I can still independently move these around. If I want the character to, for example, if I want the character to go cross-eyed, I can just kind of push these two locators in like this. So it goes a bit cross-eyed. Okay, so those are constraints, which are fantastic for rigging. With that said, don't forget to check out the other videos that show different linking systems. That's the combine and separate video, and also the parenting and grouping video. And I'll see you next time.